I only see one person online. Okay, we do have element set 4. There's a quiz in Canvas. I told you guys at the beginning of the week that set 4 was today. Let's see here. I heard somebody else dings. Let me let everybody get myself situated since I just got back, and everybody else has to get into Canvas. Okay, I got more people coming on. I see Alexis. Oh, that's the wrong period. Slates. Alexis. Caitlin. All right, in here. Jared, Brianna. Okay, I see those two. Sahara, Tiffany, Lucas. Let's see this one. See Alexis, Jimmy, Sebastian. Do not see Matthew. Kyle. Oh, I got your email, and one of those, yes, it was in Canvas, but I hadn't moved it to Parent Portal. So I fixed that this morning. I did see your email. Veronica, Valerie, Luke. Where is he at on here? It's Luke. Hayden. Oh my goodness. Nora's over there. Don't see Braden. Don't see Eva. Okay, so you guys in Canvas, you do have set 4. Just the matching thing shouldn't take you very long. And then I was going to do a Google slide today, but I'm pushing that one to Tuesday. We're going to do the harder, covalent Lewis dots. We're going to do those Monday. I'll be here Tuesday. All the chemistry teachers have the day to plan. We call them PLC days. So what I'm going to do instead is we're going to do a FET lab.
What?
FET. It's a virtual FET lab. Virtual. You guys know we're not allowed to let you touch stuff because of COVID. That's what I was just talking to Mr. Cobb about. It's like, I was just, COVID ruins everything, huh? No, not with goods. We haven't even built compounds yet. We can't play with chemicals. You don't know what they are yet. Oh, goodness. No, we're not going to blow anything up. Okay, so let me, I didn't present my tab. I apologize, you guys. All right, so for those of you that are remote, I could have sworn I did. Uh-oh.
Faculty and students, at this time, please evacuate the building to your assigned areas for a fire drill.
Oh, okay. You know what? I guess those of you online, if you really want to, you can go stand outside for 5 minutes. Hey, at least it's not raining and it's not like 10 degrees. Y'all can leave everything here. I'm going to shut them off the door. So, okay. That handshake is Come on. This, and I need my blue folder. Come on, there's a fire. Fire. You're burning. Let's go play outside. Oh. Let your phone burn. Come on, the fire drill. Yes, you have to go. Let's go. Yes, you have to actually go. No, you cannot just stand outside the door.
Just starting that quiz.
What?
No.
Because you're too
I have
short.
to use my leg muscles today, so I have
You're
to
too
march.
short. I believe you.
No, you're just a freaking giant.
That's what I said.
Well, then-
Hey, now that we're back, if anybody is new on, we just had a fire drill. So, so get back into Canvas if you did not finish this quiz yet, or get into Canvas if you hadn't gotten into it yet. Okay, let me finish taking attendance here real fast. Let me see online. Oh, here, let me put my emergency folder away. Okay, now once you are done with this, the link to the FET lab is in Canvas, and you can do everything that's online. Okay, but I do have a paper version if you'd rather do it. There's two little typos on here that don't match up with the slide. But they're already printed off, and I didn't feel like printing it again. So let's see. In Canvas, it's the 1113 element set 4, and then below that is that FET virtual lab. Let me double check and make sure that I did not. Edit. File upload. Okay, I did. And make sure that I gave you the ability to send something back. Go back into, where'd my FET lab go? You're hungry.
I gave you a start code.
Okay, now for those of you that are virtual, since you don't have a paper version of this, there's sort of like a drag and drop for the molecules. When you do get here, let me show you. When you do get into this FET lab, when you get into the Google, here, into the link, to this link, this Google Doc link, there is going to be, you can't see what I'm showing them. I have to sneeze. I can feel it. Feel it. Okay, so in Canvas, you've got, once you're done with your quiz, you click on the link for the Google Slides. And it should be this guy. Okay, and it's going to bring up, it's only four things long. That doesn't, yes, that's right. Okay, and then there's a link here. Now, we haven't done covalent yet, so if you want to start with ionic first, you can. Okay, but this is going to introduce covalence as well. But when you click on this, click on this FET lab, and it tells you the order to do stuff. Choose the model screen, click on the molecular, let me make sure I did the right one. Click on the molecular model, click on these things, and you can change. You're going to have to be able to go back and forth, but it tells you what to do. And then you can, if you want to do this completely on there, you can. You can actually drag the structures over, which we have not gotten into Vesper shape yet. That's what we're going to be doing Monday. But these virtual models, it tells you what to add, and it will, like the first one is linear, which is already done for you. Add 2 atoms to the center, it's linear, it's done for you. Add 3 atoms to the center, you're dragging and you're adding. So adding a third one in, what does it do to it? What does it look like? If you're adding lone pairs of electrons, you're going to, you may have to split screen. Now, if you want to do this on paper, and you'd rather draw this instead of it doing it, it'll make this stuff for you. Who wants to do this on paper instead of the Google slide? Okay, if you do, I'm just going right here. The only thing that's different on the paper than what's up here is these two. If you're doing everything online, it's correct up here. Adding 2 atoms with lone pairs of electrons, adding 3 atoms. I didn't fix it on here before it was printed. This, if you do the paper, it says add 5 and add 6. Don't do it, change it to what's up there. Okay, so let me go back. You get rid of this guy. Okay, so if you're doing, you should be able to click and get into the little lab. Okay, and it says choose the model screen, or even if you just want the paper to be able to do the instructions so that you're not having to go back and forth for reading it. So you click onto your Fet Lab. Oh man, this is too small for me to read. Choose the model screen of the simulation, which is this guy over here. Click to enable the molecular geometry feature at the bottom. Be this guy. And click the enable bond angle feature to the right. Let's see, where's the bond angle? Right here. So it tells you to click both of those. So back on the lab. You get rid of this again. See this link? That. And takes you to it. And then you click on it. You got it? Okay, and I should be sharing my screen here. I'll do it one more time. So on the Google slide, there's this link. There's another one here. Okay, so but in the purplish or the molecular, that's the one we have not done. You're playing with these. Even though we haven't talked about bent and trigonal planar and tetrahedral, you're getting the chance to actually play with this virtual lab to see that they're three-dimensional. And we draw things flat on paper, but it turns it into a 3D thing. I actually have a molecular kit somewhere, but I don't know where I put it. So you click on this link. It's you click on your screen. Go ahead and click back on it again. It tells you to choose the model. Then it tells you click to enable the molecular geometry feature at the bottom. That's right here. And then it says click to enable the bond angle feature to the right of the screen. It's this guy. And it says, as you explore, you get to play with these things. As you explore, answering the following questions. Using the model screen, add bonding domains, atoms single bonded, to the central atom. Using lines, wedges, and dashes from model 2, draw each molecular shape. So the first one is done for you. It says add to the center. So this is the center, okay? You have an atom here. You have an atom here. This is linear, which is 180 degrees. Like the first one is done for you on this already. Then it says add 3 atoms to the center. So we're going to bring in a third one. And on this, which one of those is being represented by this? This guy right here. The one that looks like it. There you know what? I shouldn't be doing. Let me open up. I just realized that this is the one that controls what you see. Home. If I do it on here, it's gonna edit all of your documents. I don't want to do that. That's what happened with the make a copy. Not this one. Oh, where'd it go? Oh, there it is. I apologize. I just realized if I keep doing that, then it's going to change my original one. Okay, so going back and forth. Okay, so what is the angle? What's going to be on the right-hand side? 120 degrees. Okay, and then I think it's going to be easier for you just to drag these puppies over. So that's this guy right here. Okay, and then this is what it's called. So it says it down here. What is the shape of this? It's down on the bottom left where it says molecule geometry. Trigonal planar. Okay, so that's what you would put here. And what did I say? It was 120 degrees? You would do basically a 0, and then you would highlight it, and you would hit control period. Makes a superscript. You're going to add another one to the center. So another one. And then you can sort of move this thing around. So, oh, I hear something online. Okay, well, I actually have my screen shared. So Luke, let me get you started. So in Canvas, you're going to click on this link. And it's, oh, there's also a quiz. There's the element quiz set 4 that you need to do as well for the opener. But you click on this link and it's going to open up a Google slide. And what we've done is we've clicked on this hyperlink and it opens up a PhET lab. And we have not done molecular yet. We have done ionic, but this is allowing you to create these three-dimensional molecules. And we actually just did the first one together. The first one was done for you. It's already got 2 atoms attached to the center. When you first open, here, let me just show you. When you first open the lab, you may have to split screen. It tells you to click on the model, tells you to click on molecule geometry and to show bond angles. So, and you can drag stuff. So this was over here. I'll go over this again, just in case anybody missed it. So the first one is already done for you. It's this, okay? And you can sort of drag it around if you want to make it nice and perfect, but this is the name of the geometric shape. It's in a line. We call it linear. It's in a straight line. So this angle is 180 degrees. And then if I need to move that to this side. There we go. So this is what it looked like. It is linear. It's 180 degrees. And then it says to add an extra atom to the center because it already had 2. So you're literally going to drag a single atom into the center. And it changed the shape to trigonal planar. So this is trigonal planar. You missed our fire drill. And then that is 120 degrees. Oops, I have it as a, make that a degree symbol. And that is this shape right here. And then you're going to add another one to the center. It's going to change the shape's name down here on the bottom, and it's going to have a new angle. And you're going to do that, and then you're going to drag the right guy over. Then you're going to have to reset it. Now I got to figure out how to reset. Remove all. Okay, so you had, that's a triple bond. We're doing, okay, so it says add 2 atoms to the center and 1 lone pair. So we've got 2 atoms to the center, and it's to add a lone pair of electrons. It doesn't show what? That's this. Okay. See, that's what I said. You haven't done that yet. You don't actually see them. Okay, so if I draw it on the board, and this is unfair to the people that are online. If you have a central atom, like oxygen, and you have 2 atoms that are attached to it, you're going to have lone pairs of electrons that push those hydrogens away. We call this bends. It's the one that basically, it doesn't have this. It's the one that, it's not straight on a line, they're bent down. And there is one that shows that off on the side. We didn't have any of this cool, fancy stuff when I was your age. We had these little, like, they look like Lego kind of things that we put stuff together. I don't know where I put my kit. Okay, so most of you, and then, like I said, on the paper, and I'm glad you guys are all doing this virtually and not on there, because on the paper it's different, but you're going to add 3 atoms to the center. So basically from this one, you're just going to add an extra, and it changes. And you can drag them around to see what things look like. Keep in mind, as you're dragging it, those angles are going to change until you let go, and then they stop. And then on the next part, let me drag this stuff out of here, change it so that I can do this in 8th period. Okay, switch to an explore real molecules screen. Yes. So we would go back to I don't know. Who is it from? I don't know. You may want to just in case. But so for the second slide, you're switching to real molecules. Actually, I want to remove all. So we're going to check your answers from the last question and see if you built these molecules correctly. Go to the drop-down menu and choose the molecules you drew out to get the answers below. Okay, I have not used this slide yet. Ow, that's going to bruise. So H2O, molecular geometry. So that this is a water molecule. It's actually what I have up on the board. So like this is one set of, like if I can get it to, if I can get, oh, well, okay, it doesn't want to. There. Yeah, this is neat. I didn't have any of this stuff when I was your age. Anyways, this is hydrogen, hydrogen, oxygen. This is a lone pair, and this is a lone pair. That is going to show you your angular geometry, which is bent. What? Where? Yes, I'm sorry. Number of atoms bonded to the center, number of lone pair of domains. Okay, so what that means, you have two atoms that are attached, and how many lone pairs do you see? Those weird bubbles that look like ghosts. There's two of them. And then you're going to choose whatever it is that it wants you to choose going down that list. The ionics, go back to what? Go back to this? Go back to this? What's wrong? This, okay, so the molecular geometry is right here. Okay, and then it asks you number of atoms bonded to the center. That's the filled in circles. There's two. There's two. And then it wants to know how many lone pairs, and that's the thing that sort of looks like a ghost sticking up off the side. And then you're just going to change. So the next one is what? Carbon dioxide? CO2. There's still two atoms bonded to the center, but it's not bent. It's in a straight line. We call that linear. Now they happen to be double bonds, not single bonds. When we talked about, when we did the types of bonds, 2 days ago, we said that covalent bonds, they can be single, double, or triple bonded. The stuff that you're exhaling has double bonds in it. It's just its structure. I mean, if it was pure carbon dioxide, yeah, you'd suffocate and die, but I mean, you're exhaling it and you're alive over there. Pure carbon dioxide would kill you. So, I mean, anyways, you're going to do that for each of them, and then you're going to switch over to the, I almost got rid of it, to the ionic stuff. You're going to click the other link, and you're going to follow along with it too. Okay, I need to make sure I haven't missed anybody first. We've had cloned animals for quite some time. You can actually clone your own pets if you got enough money for it. Mm-hmm. To my knowledge, the humans have not been done. Not, at least not in this country, because that's not ethical. Did we not have that conversation one day where women can technically give birth to their own clone and grow their own spare body parts? With science, you can take one of your own, of course it have to be a girl. You could take one of your own eggs from your ovary. You can strip the DNA out of it, so it's like an empty egg. You can take your own DNA from your real cells, inject it into the egg, reimplant it inside yourself, and give birth to yourself. I am not joking. You're looking at me like I have horns growing out of my head. I am not joking. Now, have people done that? Not to my knowledge, but is it possible? Yeah. It's amazing what we can do with technology. Women don't even need men anymore, but they can only have baby girls. You can take two women and you can take their DNA and you can fertilize an egg. They just wouldn't be able to have a boy. I don't know if anybody's done that. I mean, but it's possible. The egg doesn't care. It just wants another half of DNA. It doesn't care if it's an X or a Y. It doesn't care. It just wants the other half of the DNA. So you could take two women's eggs, one from each. You could take the DNA from one and put it in the other, and voila, they have a baby girl with their DNA. It is amazing what we can do with technology now. But there would be no more baby boys. They couldn't have a baby boy. You could only have a baby girl because we only carry the X chromosome. We can do all different kinds of stuff with technology. Okay, so, all right, so once again, you're using these, you've got the model, which is the first slide, and then you've got the real molecules, which is the second, and then you have here's the ionic one. Then you have the stuff for the ionics, and you're just following along and filling this in, and then you can save it and upload it. Now, I'm going to stop sharing. I'm actually going to stop the recording that I have because I need to go through